The I can statement for today is I can know and apply the properties of exponents to generate equivalent numerical expressions. Sorry, there's a typo there. So first off, we need to talk about what an exponent is. If we look at this first example, the exponent is that little number that's up high. We have talked about this, and previously we've called it a degree. For example, this is a monomial of degree 2, right, where the base is x. So we've got our base is x, the exponent is 2. If we look at the middle problem, right, notice what's being raised to the third, the m, the 2, or you want to ask yourself, is both. And if you look at this problem, you actually realize the base is m. Just the base is m. Because the 2 is not being raised to the third, just m. And then if we look at this next problem, the base is 3n because the 4, this exponent, is affecting both of them because of the parentheses. All right, so we want to just write this out real quick. So 7 to the 4th is the same thing as 7 times 7 times 7, 4 times. Then I want to multiply that by 7 to the 5th, so that's 7 times 7, 5 times. Right? Well, if you look at that, we see a bunch of 7s being multiplied together. How many of them? We have 9 of them, so we have 7 to the 9th. If we write this second problem out, first off, I have this negative 4x squared. So remember, when you square something, you just times it by itself. So I really have negative 4 times itself times, now let's do the second part, negative 4 cubed. So I got negative 4 times itself 3 times. Should end up looking like that when you write it all out. Well, if you look at that, that's just negative 4 times itself 5 times. So we've got negative 4 to the 5th for our simplified shorthand. And we can do that with the last problem. Right, same concept. I've got an x here, so I'm just going to write that as an x, times, if we look at this next piece, you got x to the 5th, so write that out as x times x 5 times. You have, if we look at all of them, you got a bunch of x's multiplying together. We actually have 6 of them. Okay. And so what we want to look at is what the rule is here. Right? Repeated multiplication. If you multiply something by itself multiple times, what are we doing with the exponents? So that's the question we want to ask ourselves. How can you take 4 and 5 to get 9? Most of you are already saying, okay, well, it's 4 plus 5. So let's check and see if that works for the second one. Is 2 plus 3 going to equal what we have over here? And yes, it does, right? We get 5. The exponent there is 1, so 1 plus 5 gives us 6, which is the exponent we have here on the right when we write it as shorthand. So our rule, our general rule, when multiplying, you take the exponents and we add them. So there's our first rule. So make sure you fill that in. And we're going to go ahead and give this a try. So I've got 5 to the 2nd times 5 to the 3rd. That becomes 5 to the 2 plus 3, which is 5. And you could go ahead and type that in your calculator and get a number out. Now if we look at these ones, the bases don't match. Write that down. If the bases don't match, you can't combine the exponents, so our final answer is just going to be n squared m to the 5th. So base has to match in order for this to work. We look at this third example, the bases do match, they're both 5s. Right, so we can combine those exponents. We want to add them together, so let's go ahead and take the exponents and add them. We got 1/2 plus 3/2. When you add fractions, you just add the top number, denominator stays the same. We have to have a common denominator. which we already have. They both have a 2, so it's a common denominator. When I add these together, I just add the top. 1 plus 3 is 4. Denominator stays the same. 4 divided by 2 is 2. So the final answer here is going to be 5 to the second, which you know is 25. I can do that one in my head. So if we look at the the fourth one, we do the same thing. We want to add these exponents. So I've got 2 to the third, 2 thirds, plus 1 6. Now notice these don't have a common denominator. The denominators are not the same. So what I want to do is find their least common multiple. How I'm going to do that is I'm just going to take the denominators and write out all their multiples. So let's start with 3. Okay. I'm just going to count 3, 6, 9, 12. Those are some multiples of 3. I could keep going. Then I'm going to take this 6 and write out multiples of 6. So I got 6, 12, 18, and so on. What I want to do is find the smallest one that they have in common. So if you look, this list does not have a 3, so 3 is out of the question. But they both have a 6. So 6 is going to be the common denominator I shoot for. Well, if I look at the fraction on the right, that one's already a 6, so that one's good to go. What I got to do is find a way to make the fraction on the left have a 6. So you ask yourself, what number times 3 gives you 6? And we say 2, because 2 times 3 is 6. So what we're going to do is go ahead and multiply the top and bottom of this equation, this fraction, by 2. When you do that, we multiply the top with the top and the bottom with the bottom. 2 times 2 is 4. And then on bottom, 2 times 3 is 6. So I really have 4 sixths plus 1 sixth, which is, remember our rule, you add the tops together to get 5 6. And hopefully this is a review. Okay. So our final answer is going to be x to the 5 6. Now I just want to note that your calculator will add fractions and multiply fractions for you. So if you got the 30xs, you're good. You can just plug those in your calculator. But make sure you know how to add and multiply fractions and things like that. Okay, go ahead and practice. I want you to pause the video for just a minute, try out those 3 problems, and then I'll throw up the answer. All right, if you look up there, I have the answer to the first and last problem. I just want to talk about this middle one real quick. If you notice, the negative is inside the parentheses here. So if you were to type this in your calculator and simplify, make sure in your calculator you hit the open parentheses button, then the negative button, then the 6, close parentheses to the 5th, then hit enter, and it should give you negative 7776. So this is the answer for that one. And again, notice that it is still negative, right? Okay. Next rule we want to take a look at. I want to write it out. So I want to express it as repeated multiplication. So first off, I have 5 to the third and it's being squared. So I need to write that out. 5 to the third squared is 5 to the third times itself. All right, so I've just wrote that part out. I just did the squared part. So that's what you see there. So now I'm going to go ahead and write each of those out. 5 to the third is just 5 times 5 times 5. And 5 to the third is, again, 5 times 5 times 5. Now, if you notice, I have a bunch of 5s multiplying each other. I actually have 1, 2, 3, 4, 5, 6 of them. So I really have a 5 to the 6th. Let's go ahead and try the second one. All right, I have negative 6 squared to the 4th. So let's write out a negative 6 squared 4 times. So I got negative 6 squared times itself 4 times. That's all 4 of them. Okay, so I wrote that first part out. Now I got to go ahead and write each of those out again. Right, they're all being squared, so that's timesing it by itself. So I've got negative 6 times itself for squared. Then that's going to multiply the next piece, so negative 6 times itself again. And that's going to multiply the next piece. Negative 6 times itself. And then negative 6 times itself again. So we wrote that whole thing out. Okay? And if you ever forget the rule, you can always go ahead and just write it all out, which is why we're doing this. So go ahead and count how many negative 6's you have timesing each other. I have negative 6 to the 1, 2, 3, 4, 5, 6, 7. Looks like 8 of them. So that's my simplified form. All right, last problem. Let's go ahead and try this one. Again, I'm going to take a squared and cube it. So I got to write a squared times itself 3 times. So there's all 3 of those. And then let's write it out again. So a squared is just a times a. Then I have a times a again, and a times a again, which if you look at that, you have a bunch of a's. You got a to the 6th here. Okay, so what we want to do is try to find the rule. Now, if you look at this, what operation could you do with 3 and 2 to make it equal 6? Okay, and the operation would be to multiply, because 3 times 2 is 6. So let's go ahead and test that theory on the rest one. So I got 2 times 4 equals 8, and I just want to check and make sure that's what I got over here, which I did. All right, test it on this last one. 2 times 3 equals 6, which again is what I have over here. We're happy. We know the operation is multiply. So the rule here is when you have a power, this is this m, if you look at this, when you have an exponent and you raise it to another exponent, the rule is going to be m times m, which means multiply. So power to power, we multiply. Okay, quick review, if I just go back, power to power, you multiply. On these ones, when we're multiplying them together, right, I take m to the 6th, I times it by m to the 4th. The rule is to add, right? The rule is to add. So when you multiply the variables or the same bases, you add the exponents. When we have power to power, like you see here in this example, power to power, we're actually going to multiply. So there is a big difference. You got to make sure you understand the difference and don't get them confused. Okay, so here's some examples. Power to power. I'm going to just go ahead and multiply those. I got 3 times 4 is 12. So I really have a negative 2 to the 12th. Which if you plug that in your calculator, again, make sure you put the negative in the parentheses. Right? And when you raise that to the 12th, you should get a positive 4,096. Right? And quick idea behind this, if you take negative 2 and square it, that's really negative 2 times negative 2. Right? And when we do that and you multiply a negative times a negative, you get positive, which is why we get positive for when we square a negative number. Right? But if we look at, if we cube that number, so let's say negative 2 to the 3rd, right? That's negative 2 times negative 2 times negative 2. 2 of these negatives cancel out, but notice there's that 3rd one that makes it negative. So whatever your answer is here, you're going to get a negative 8. Right? It's going to be negative. Then we could keep going. We could say negative 2 to the 4th if we wanted to take a look at this. Right? We got negative 2 times itself 4 times. When we do that, these 2 negatives cancel to give us a positive. These 2 cancel to give us a positive. So whatever our answer is, it's going to be positive. I think that's 16. Right? Are you starting to see the pattern here? Hopefully you have. Big idea behind this is if you square a negative, it becomes positive. Right? If we cube a negative, it stays negative. If we fourth a negative, it becomes positive. So hopefully you're starting to notice if it's an even power, it's going to be positive. If it's an odd power, it's going to be negative. So make sure you take note of that. Write it somewhere nice and big so that you remember that, because it's going to be a lot easier to just do those in your head than on your calculator. And generally, if you type in your calculator, we could type it wrong. So let's go ahead and look at this second problem. Power to power, we multiply. 5 times 3 is 15, so I have a negative 3 to the 15th. So let's go ahead and apply our theory here. I've got a negative, and it's being raised to the 15th power. 15 is odd, so your answer should be negative, right? So plug negative 3 to the 15 in your calculator. When you do that, you should get this gigantic number here. But notice it's negative, right? Okay, third example, power to power. We multiply. 5 times 2 is 10. So what I have here is a negative on the outside, 3 to the 10th, right? Notice this negative right there is not within the parentheses, which means it's not going to be affected by these two exponents. Those two exponents are just affecting the 3, okay? So that one will stay negative, even though the exponent is positive, because it's not, the exponent's not affecting the negative. So now you can type negative in your calculator, open parentheses, 3 to the 10th, then close the parentheses if you want, or you actually don't even need parentheses. In this one, if you just didn't even put those, it would know that you're not sending the 10 exponent to the negative. So type negative 3 to the 10th, and you should get a negative answer. Looks something like this. Okay. All right, last problem, power to power. Again, we multiply. So you want to take 5 and you want to times it by 3/4. Rule for multiplying fractions, you got to make both of them a fraction. So I'm going to put that 5 over 1, right? That's the same number. You multiply the top with the top. 5 times 3 is 15. And then you multiply the bottom with the bottom. 1 times 4 is 4. So this becomes x to the 15 over 4. And you could just plug that in your calculator. But just know when you multiply fractions, you multiply the top two numbers, then you multiply the bottom two numbers. All right, go ahead and practice. Pause the video for just a minute so you can think these through on your own before you check your answer. Okay, go ahead and check your answer there. Notice that second one, the negative is inside the parentheses, so it is being raised to the 4th power, and that's an even exponent, so your answer will be positive because this negative is going to go away since it's an even exponent. Okay, our next example, and we're actually going to start with the rule here. If a and b are real numbers, and m is an integer, and n is an integer, m is an integer, then a times b raised to the m is going to give us a to the m and b to the m. So basically, you just got to make sure that if the m is supposed to go to everything inside the parentheses, that it actually goes to each piece within the parentheses. So let's go ahead and practice that. This 2, this exponent, needs to go to every single thing within inside the parentheses. So I'm actually going to start with a negative. If you square a negative, right, it's an even power, it's going to become positive. All right. Let's take that 2 and drop it to the 3. Our rule is power to power. We multiply, but you need to recognize here that the exponent by the 3. So if we look at this 3, it doesn't actually have an exponent. If it did, it would be a 1. So the power to power rule here is 2 times 1, which actually gives us a 3 squared, right? Which makes sense. You're squaring the 3. And then we look at our next one, and we make sure that this power goes to the n. Power to power, 5 times 2, we multiply to get 10. So your final answer here should be positive 9. 3 squared is 9, and to the 10th. Okay. If we look at this middle one, again, we just got to make sure that the exponent, the 7, goes to everything. So let's first bring it to the m. 2 to the 5th times 7. Power to power, we multiply. So we end up with m to the 14 over 5. Then make sure you get that 7 and distribute it to the n. So we have n to the 3/6 times 7. You can plop that in your calculator or just do it in your head, and you end up with 21 over 6. So that's when you have multiple things inside the parentheses, the power has to go to all of them using the power to power rule. So real quick, I'm just going to simplify this problem here. Looks like a 3 goes into both 21 and 6. 3 goes into 6 2 times, and 3 goes into 21 7 times. So that fraction reduce. We just need to reduce. Final answer is m to the 14 fifths times n to the 7 halves. Okay. All right, go ahead and practice these two on the right. Just going to give you a minute to try those. Okay, check your answers, and I guess real quick we'll just talk about this. Again, power to power means you multiply, but you multiply the exponent. So this 2 has a 1 there. 2 to the 1 is just 2, right? You don't write the 1. It just goes without saying. So 3 times the 1 gives you a 3, right? And 2 to the third gives us this 8 here. So you got to make sure you have an 8 there instead of a 6, because that's a common error that occurs with exponents. Okay, quick new rule. Anything raised to the 0 power is just 1. You could plug any number into your calculator. If you plugged this first number in, notice if you plug it in a calculator just like this negative is not being raised to the 0. So when you plug it in your calculator, 7 to the 0 equals 1, and then you actually have this negative that's out front. So our final answer for this one would be negative 1. If we look at the second problem, notice the negative is being raised to the 0, right? The 0 exponent is affecting both the negative and the 3, so it makes this entire piece equal 1. So final answer for this one is 1. Make sure you get the difference here. The parentheses makes a big difference. The whole problem is 1, so our final answer is a positive 1. This one doesn't have parentheses, so the 0 only affects this 7, and that negative just stays there. All right, so just go ahead and practice. Pause the video for a minute, see what you can figure out with these 5 problems. Okay, go ahead and check your answers here. You see for the first 2 problems, the answer is 1. If you look at that top right problem, real quick, I just want to emphasize that in between the 2 and the m, it is multiplying, right? It's 2 times n, even though you don't see the multiplication symbol. So when we're doing this type of problem, the base is m. So m is the only thing being raised to the 0, which means m to the 0 is worth 1. But this 2 is not being raised to the exponent, so it stays there. And again, the 2 was multiplying the m to the 0, so now the 2 is going to multiply the 1 to give us 2. Same thing happens for the bottom 2 problems, so just make sure you check and work through those really carefully. This is just a quick review of the property of exponents. Right? Make sure that you recognize the difference. When we multiply them, we're actually adding. Okay, that's kind of the tricky thought. Power to power, now we multiply. Maybe write that down just so you kind of remember. Quick review. Again, when you have multiple items being raised to the m, just know that the m has to go to both of them, or all 3 of them, or all 4 of them, however many items are in there. And then anything to the 0 power equals 1. So that's just a quick review of everything you've learned today. You need to have these memorized for your test.